everyone, today we will talk about enzyme nomenclature and classification. Conventionally, enzymes have been named using adding A's to the substrate. For example, enzyme hydrolyzing sucrose is commonly known as sucrase, or even amylase is the enzyme which hydrolyzes amylose, which is starch, one form of starch. Similarly, some enzymes have been named based on their function, like pepsin. Pepsin was first extracted from the stomach, and it was known to be more in digestion. So that's why the name pepsin was given, because pepsis means digestion. Similarly, trypsin or chymotrypsin, all the proteases, they are exception to the name adding ase. They have been in fact used by adding in at the end. Then other enzymes are based on their function, like DNA polymerase. DNA polymerase is an enzyme which causes polymerization of deoxyribonucleic acid. Similarly, lysozyme hydrolyze cell wall of bacterial cell wall, and because lysis means breaking down, that's why lysozyme was the name given to the enzyme responsible for breaking down cell wall of bacteria. So these all traditions are non-scientific, and that led to, in fact, new enzymes are being discovered, and there are chances that one enzyme or more than one enzyme are given same name, because this nomenclature method is not scientific. So that's why in 1961, International Union of Biochemistry, which was later known as International Union of Biochemistry and Molecular Biology, they have set up Enzyme Commission to give some number to the enzyme and a specific name based on the reaction they catalyze. Okay, for example, glucokinase is an enzyme which transfers phosphate group to glucose from ATP molecule, and the product is D-glucose phosphate, and ADP is released. This enzyme is commonly known as glucokinase, but glucokinase doesn't give any information about the reaction catalyzed. This is trivial name, is a common name for the enzyme. Enzyme Commission has given a name to this, that is ATP D-glucose phosphotransferase. If you look at this name given by, specific name given by Enzyme Commission, it clearly indicates the how this reaction is being catalyzed by this enzyme, ATP D-glucose phosphotransferase. So this enzyme transfers phosphate group from ATP to D-glucose, and along with this, Enzyme Commission has given one 4-digit number also. For example, 2.7.1.1. So this number is very specific to each and every enzyme. Enzyme nomenclature and classification is a system that unambiguously identify an enzyme based on the reaction the enzyme catalyzes. So this system relies on 4-digit numbers. These 4 numbers are separated by dots, and each number, the first number, represents the main class of that enzyme. Second digit is subclass, third digit is subclass, and the last digit is a specific number to given that enzyme. This is what was decided by Enzyme Commission, so that when new enzymes are discovered, there is no ambiguity in their nomenclature. Enzyme Commission classified all the biochemical reaction into 6 classes, and eventually in 2018 7th class was introduced. So these 7 classes are Oxidoreductase. To remember them, you can write them OTHLILT. So these are 7 classes. Oxidoreductase is these enzymes catalyze redox reaction where oxidation and reductions are occurring. It means there is a transfer of proton, oxygen or electrons in the reactions. Second category is transferases. These enzymes catalyze transfer of one group from one chemical to another chemical. Then third category is hydrolases. These enzymes are responsible for hydrolytic cleavage of substrate molecules. Then fourth class is Lyases. This lysis enzyme catalyze splitting of molecule without involvement of water. Then fifth category is Isomerases. These enzymes catalyze isomerization reactions from, say, for example, D-alanine to L-alanine and so on. Then sixth class is Ligases. Ligases are the enzymes which catalyze joining of two molecules together and forming a single product. Then seventh classes, which are introduced recently, is Translocases. Translocases are the enzymes, or they are proteins which are embedded into lipid bilayer, and they help in transportation of ionic or polar molecules across the lipid bilayer of cell membrane. For example, you have transportation of glucose transporters, or sodium or potassium ion transporters, and so on. Those all transporters, they have been categorized into the seventh category, which is called translocase. So as per the Enzyme Commission, the first number given to any enzyme is the main class, and we have 7 main classes which are involved in different reactions, biochemical reactions in a cell. The first main class of enzyme classification given by Enzyme Commission is Oxidoreductases. These enzymes catalyze transfer of H plus ion or electron from one substrate to another substrate. Is a vast class comprised of all dehydrogenases, oxidases, oxygenases, and peroxidases. So, for example, let's take oxidation of lactic acid. Lactate dehydrogenase is a very common enzyme which oxidizes lactic acid, CH3CHOH to pyruvic acid, CH3C double bond OCO. So this OH group become oxidized, become keto group, and it forms pyruvic acid. And simultaneously, the proton, the hydrogen atom from here, is taken up by a hydrogen acceptor called NAD. Nicotinamide adenine dinucleotide is a very common hydrogen atom acceptor in biological systems. So NAD accept this proton. As a result, NAD become NADH, and lactic acid become pyruvic acid. Now, when you give nomenclature, when you give Enzyme Commission number to this enzyme, the first number is always the main class. The main class is Oxidoreductase. The second number is the second digit in Enzyme Commission number represent subclass, and this subclass depends on hydrogen or electron donor. In this biochemical reaction, which is the group is donating hydrogen atom or electron. If alcohol is the donor of hydrogen or electron, the second digit is 1. If aldehyde or keto group is there as a donor, the second digit would be 2. If is alkene group as a donor is number 3, number 4 primary amine, number 5 secondary amine, and number 6 if NADH or NADPH is working as a proton donor or electron donor in the biochemical reaction, the second digit will be 6. So subclass of oxidoreductases is defined depending on hydrogen or electron donor. So if you look at this reaction, which group is working as a donor of hydrogen atom in this reaction? Lactic acid is converting to pyruvic acid, so this COH group is becoming C double bond O. So proton donor is OH group here. It means lactate dehydrogenase. If you want to give Enzyme Commission number, the first digit would be 1 because it's belong to oxidoreductases family. Second digit would be, if you look at the second digit, subclass OH group. OH group is donor of hydrogen atom here. So second digit also would be 1, and the third digit would depend who is accepting this proton. If NAD plus or NADP plus is working as an acceptor of the proton, the third digit would be 1. If Fe3 plus is there to accept the electron, it is number 2. If oxygen is working as an acceptor, the third digit would be 3. And if any non-classified acceptor is there, you call it 99. That's how 3 digits can be assigned as per Enzyme Commission to every enzyme falling into this Oxidoreductases family. So lactate dehydrogenase, if you want to give its numbering, it would be, Enzyme Commission number would be 1 because it belongs to Oxidoreductase family, then dot. Second, in the reaction, hydroxyl group, alcohol is working as a donor, so second number also would be 1. And who is accepting this hydrogen? In this reaction, NAD is accepting. So when NAD is accepting, the third digit also would be 1. So these 3 digits can be defined as 1.1.1 for lactate dehydrogenase. Then fourth digit is basically a specific number given to the enzyme by Enzyme Commission to lactate dehydrogenase. That number is given 27. This is as per convention. So for lactate dehydrogenase enzyme, this Enzyme Commission number would be 1.1.1.27. So this itself describes which reaction it catalyzes, which group is there to donate proton, which group is there to accept that proton, and everything about this reaction can be depicted from these 3 numbers. And fourth number 27 is dedicated to lactate dehydrogenase enzyme. So lactate dehydrogenase is a common name. The scientific name for this enzyme would be lactate because it acts, lactate is substrate for this, lactate NAD plus oxidoreductase. So that will be scientific name for this enzyme, which involves name of the substrates and the main class oxidoreductase. So this is lactate NAD plus oxidoreductase, scientific name for lactate dehydrogenase enzyme, and Enzyme Commission number 11127. Second main classes of enzymes is transferases. Transferases, as the name suggests, they transfer groups or atoms from one substrate to another substrate, and that's how they are called transferases. So second digit, the subclasses in under transferases, they would depend on the group transferred, which group is being transferred, whether it's a 1 carbon group or is aldehyde or keto group. Accordingly, the numbers are given in subclasses. So if it's a 1 carbon group, this number is given 1. If it's aldehyde or keto group which is being transferred, is number 2. If a acyl group is there to be transferred, is number 3. If glycosylic group is there, it's number 4. If aryl or alkyl group is being transferred, the number is given as 5. For any nitrogenous group, number 6. Phosphorus group, like you have kinases, phosphotransferases, so the number is given as 7. For any sulfur containing group, number 8. Selenium containing group, number 9. And molybdenum, number 10. So that's how the second class is given numbers at the transferases. Then third digit represent subclass under transferases, and the example is if under say one carbon group, if this is methyl group which is being transferred, is given number 1. If it is CS2OH group, then it's number 2. If it's a carboxyl group, it's number 3. So each subclass here may have a third digit depending on which is acceptor atom. For example, we'll not talk about all the subclasses, but let's take example of phosphorus. Phosphorus means when you have a 2.7 transferase, and phosphorus is the group which is being transferred. That's what happens in kinases, what you call phosphotransferases. If the phosphate group is being accepted by any alcohol group, means it's being transferred to the OH group, the third digit is given 2.7.1. So 1 will be number for acceptor of phosphate is hydroxyl group. If phosphate group is being transferred to carboxyl group, this number of third digit would be 2. If any nitrogenous group is accepting the phosphate group, is called number 3, or if there is a phosphate group accepting the phosphate, is called number 4. So that's how kinases can be given numbering 2.7.1 or 2 or 3 or so on. The third main class of enzyme classification is hydrolases, and it is comprised of esterases, proteases, glycosidases, nucleosidases and lipases. It's also a vast category, vast class of the enzymes, and these enzymes split molecules into two parts with the help of water. That's why you call them hydrolases. The second digit, the subclass under this category is defined on the basis of bond being hydrolyzed. Which bond is being broken by the enzyme, that give rise to the numbering scheme for the subclasses. If the bond being hydrolyzed is ester bond, the second digit or subclass would be given number 1. If the bond is glycosidic bond, it will be given number 2. If it's a peptide bond, is given number 4. If it's any CN bond except peptide, that is given number 5. Similarly, the third digit defines which type of bond. For example, in case of 3.1, in case of esters, which ester? If it is a carboxylic ester group, this number would be given 1. So the 3 digit would be 3.1.1 if it is a carboxylic ester. If it is a thiol ester, then number 2. If it is a monophosphoric ester, number 3. Diphosphoric, number 4. So that's how these 3 numbers under hydrolase family can be given depending on the bond being hydrolyzed. The fourth class is Lyases. It's comprised of decarboxylases enzymes, dehydratases, aldolase and synthases. All these enzymes fall into lyase category. These enzymes catalyze removal of group or splitting of a compound of a substrate into 2 products. It's always single product being converted into 2 products without help of water. That's the difference between hydrolases and lyses. Hydrolases require water to split groups or split molecules into two components, whereas lyses act on a single compound and split that into 2. For example, histidine decarboxylase is an enzyme which remove carbon dioxide carboxylate group from histidine. As a result, histamine is formed. So histidine decarboxylase is an example of lyses family. So the second digit in lyses, the subclass depends on which bond is being broken. If the bond is being broken is CC bond, the second digit is given number 1. If it is CO bond, number 2. If it is CN bond, number 3. CS bond, number 4. So that's how the second digit or subclass is given numbers under lyses class. The third digit subclass is defined by the group removed. After breakage of the bond, which group is being removed? For example, if the group is removed COO, if CO group, carboxylic group is being removed, the number is given 1. If aldehyde group is removed, the third digit will be 2. If carboxylic acid COCO, keto carboxylate group is being removed, the number is given 3. So that's how 3 numbers, EC numbers can be given to lyses family, and as natural, the 4th number would be for specific to the enzymes involved in the reaction. The 5th class is isomerases. These enzymes catalyze isomerization reactions. For example, L-alanine to D-alanine conversion is catalyzed by an enzyme called alanine racemase, and The second digit under this class, it depends on the type of reaction being catalyzed. If the reaction is racemization or epimerization, which means there is a shifting in plane of the group under anomeric atom, is called racemization or epimerization, the number is given 1. If it's a cis-trans isomerization, the number is given 2. If it's intramolecular oxidoreductase or intramolecular oxidation or reduction reaction is occurring as a result of isomerization, this number is given 3. Or if there is an intramolecular transfer reaction, transfer of group within the molecule from one atom to another atom leading to isomerization, that number is given 4. And the third digit subclass, it depends on which substrate enzyme is working. If enzyme is converting amino acid form into D or L, the number is given 1 if substrate is amino acid. If hydroxy acid is the substrate, the third digit number would be 2. And if it's carbohydrate, the number is given 3. So now look at the alanine racemase, the enzyme converting D-L-alanine to D-alanine. What would be the number EC, at least first three EC number for this enzyme? So this enzyme is working on alanine and it's converting L-alanine to D-alanine, means there is a shuffling, there is change of group at one carbon atom. There is a position change in the group at one carbon atom, which means it belongs to the category racemization. So the second digit for alanine racemase would be first category 5, first class number would be 5.1 because it's catalyzing racemization, and it's catalyzing racemization of what? It's doing for amino acid. For amino acid number is 1. So for alanine racemase, the enzyme commission number would be 5.1.1. And to this enzyme commission has given a specific number also 1. So the final number would be 5.1.1.1 for the enzyme called alanine racemase. The sixth class is ligases. Ligases are the enzymes which catalyze formation of new bonds, and when new bonds are formed, they require energy. So ligases take energy from nucleoside triphosphates like ATP or GTP. So for example, X and Y, two reactant, there are two substrate X and Y. Ligases catalyze one new bond formation between X and Y, and as a result NTP is hydrolyzed to nucleoside diphosphate, and this energy coming out from hydrolysis of NTP is used for formation of X and Y new bond. The second digit subclass depends on the bond synthesized. If CO bond is the new bond which is being synthesized, the number is given 2. For CS bond number 2, for CO bond number 1, for CS bond number 2, for CN bond like peptide bond is given number 3, and if it's a CC bond which is newly synthesized, the number is given 4. And similarly, the third digit subclass is based on the further clarification of the bond. For example, in case of peptide bond, CN bond, in case of CN bond, if we further categorize that, if the CN bond formation is giving rise to CONH2 group, so this is given is number 1. So for 6.3.1, CONH2 is the product, amide bond, and if CONH, the peptide bond, is the product, the number is given 2. So that's how each subclass can be further classified into subclass depending on more precise information of the group being synthesized. Before 2018, 6 different types of biochemical reactions were known. In August 2018, a new class was introduced in form of translocases. In fact, these are proteins and enzymes which are present in cell membrane, and they facilitate transport of ion and polar molecules across the cell membrane, lipid bilayer, which is made up of lipid bilayer. So the second digit, the subclass of under this class, depends on which ion or molecule, because only polar and charged compound they need facilitation in transport across plasma membrane. Hydrophobic substances can easily diffuse in the lipid bilayer because of non-polar behavior. So only ions and polar molecules require to be transported with the help of protein or enzyme molecules. So second digit depend on which ion or molecule is being transported by that enzyme. If it's a hydrogen atoms being transported across lipid bilayer, the subclass number is given as 1. If inorganic cations are being transported, it is number 2. Number 3 is given inorganic anions. Number 4, amino acids, all amino acid transporters, they are given subclass number 4 and under translocase class. Carbohydrates is given number 5. Number 6 is given any other ions which is not mentioned. And similarly, the third digit, the subclass under this translocase class is given on, numbers are given on the basis of driving force. When transportation occurs across lipid bilayer, it requires some energy. So from where that energy is coming, which is driving force for transportation, that decide subclass of the enzyme. If oxidation or reduction reaction are helping in transportation, the enzyme is given number 1 as subclass. Number 2 is given if it is coupled with the hydrolysis of a nucleoside triphosphate like ATP or GTP, is given number 2. If diphosphate hydrolysis is aiding as a driving force, is given number 3. Or any decarboxylation reaction is coupled for transportation, that is given number 4. So that's how there are 7 classes of all the enzymes which catalyze all possible reactions occurring in biological systems. So as per this classification, every enzyme is given a very unique number. So that unique number help in differentiating the enzyme from rest of other enzymes. So that's how it gives rise to a very unambiguous system of nomenclature and classification to enzymes, which was given by IUPAC. Now I am providing you some questions for practice. You are supposed to give systematic name of enzymes involved in catalysis of the given reactions and also provide first 3 digits of their enzyme commission numbers. There are 6 questions given here. You can practice them, and if you need any assistance or you want to verify your answer, just comment below the video.